that anything can be in this session. You'll see we'll have a wide variety of topics here today. We've actually got, it says in the program 4 presenters, but we've got a fifth one who's from Tanzania who had missed his visa thing on Monday, so he'll be with us. There's a surprise guest, but otherwise we have until 10:30, so plenty of time. My name is Elizabeth von Münch. I'm from Germany. I work as a freelancer for the Sustainable Sanitation Alliance, and I might as well make a plug here for my big passion, which is the Susanna Discussion Forum, an online discussion forum with 4,500 members, and any of you is very welcome to join it, to use it. If you have any discussions that come out of today which you want to continue outside past this room, then I welcome you to use the forum, and also for the presenters, they can put their presentation up there and we can take it to a much wider audience than just these 100 or so people who are in this room. So the first presenter is Jenna Senekau. She's a PhD student from the Swedish University of Agricultural Science, originally from Canada, I found out. Background is in bioresource engineering, focusing on converting waste, and she's specializing in the design of waste management systems that optimize pathogen removal and enhance nutrient removal. Okay, we've got 12 minutes. Thank you for the introduction. So we know that there's 7 billion of us defecating every single day, and that unfortunately there's 1.2 billion people still defecating in the open. But what really disappoints me is that there's still actually 4.1 billion people who don't have access to post-treatment after defecating. We've learned a lot over the last 2 days as to how this is impacting children, the spread of disease, and also impacting the environment. As much as this is a problem, I also like to see this as an opportunity to rethink how we handle our waste. Our excreta contains the same nutrients that are being used by plant fertilizer. So if we efficiently recycle our waste back into our agricultural system, not only can we decrease our dependency on synthetic fertilizer, but we can also increase improve our soil structure with the organic content. A very great concept, but obviously not being used for several reasons. A lot of challenges have been highlighted. One of them is just the aspirations of wanting a flush toilet and this concept that a dry toilet smells and that it's not as appealing. Another issue is the concept of using our own excreta as a fertilizer for food. There's a natural disgust to our excreta, and why would we want to then eat food that was grown with it? A really big challenge, though, is just the sheer mass of excreta that you have to handle, and that's why I'm here today. For my master's study, I was growing vegetables with urine to actually verify how well urine works as a fertilizer. And though I was able to demonstrate that there's no significant difference in the mass of production between urine fertilizer and synthetic fertilizer, the amount of work that it took to collect all this urine and then carry it to my plot and apply it, inevitably I spilled it all over myself. And people had to excuse themselves nicely out of my presence as they were gagging from the smell as I was collecting the urine and trying to spread it. So after my master's studies, I was like, no way is this ever going to actually be accepted worldwide, and this doesn't make sense. So now I'm with the Swedish University of Agricultural Sciences to try to design a toilet that efficiently recirculates the nutrients, but that is actually practical. So the objective for my toilet is that it's an in-situ treatment where the waste is actually minimized on-site within the toilet, and that the final output are
a dry fertilizer from the urine that has a commercial value and a hygienic soil amendment. I don't want to change how users actually interact with the toilet, but what happens afterwards. So the urine is diverted away from the feces during excretion, and then each is contained, treated, and condensed on site. The urine poses a special problem in that the nitrogen is quickly hydrolyzed to ammonia, which is volatile. And so it's hard to preserve the nitrogen, but that's the most demanded fertilizer in the world. And so that's what I wanted to focus on. So to do this, we propose an alkaline treatment followed by dehydration. The alkaline treatment works with an ion exchanger where we exchange the chlorides out for hydroxides, and this is able to increase the pH from less than 7 to above 10. And what this does is it inhibits the urease enzymes, which are responsible for hydrolysizing the urea to ammonia. So if we're able to limit these enzymes, then we can actually dehydrate the urine afterwards. So with our urine at a high pH and still low concentration, we have the next problem of trying to dehydrate the urine. You can't just simply let it evaporate because a layer forms on the top and then the water can't get through this fatty layer. So what we do is we mix it in with ash to break up the surface and maintain it at a 35-degree temperature with banks. And it was really exciting because we were able to output a pretty high-quality fertilizer. We had a 9-3-11 nitrogen, phosphate, potassium dry fertilizer. So there's no liquid disposal and no odors, and we were able to decrease the mass by 90%. And during that time, we were able to recuperate over 85% of the nitrogen. Pretty cool. The feces, as we know, poses quite a big challenge with the pathogens contained in it. And so we're looking into vermicomposting. The feces would fall directly into a bin with worms so that within the container, the mass can be reduced by up to 90%. There's already a lot of other toilets that are being designed with this concept, which is also very exciting. But the problem is the matured compost still poses a threat as it can still contain pathogens. So we would like to use ammonia sanitization in order as a post-treatment to ensure that all pathogens are eliminated. Ammonia sanitization is a technique that my colleague Annika Merton has been explaining in the past yesterday. And by mixing in 5% weight for weight of our dry fertilizer that we have, the remaining pathogens and enzymes still in the soil in the vermicomposted material, those enzymes then hydrolyze the urea into ammonia, and then we're able to sanitize this to get a hygienic output. Conceptually, this is how the toilet would come together. There's no need for big infrastructure or for deep holes. It can be a standalone unit itself or be implemented in existing households. The idea is that the urine diverting sieve would collect the urine, and the urine would pass directly through the ion exchanger so that there's no time for the hydrolysis to happen, and then pass into the dehydration module. And again, the feces will fall down directly into the vermicomposting bin. This unit would be connected to a powerful fan so that we have enough evaporation rate happening, and be connected to the toilet so that the smell is, there's a negative pressure so that the smell is taken out. For maintenance, the ion exchanger for family of 5 would need to be regenerated once a week, and this is done with some hydroxide solutions such as sodium hydroxide. The dehydration module would be needed changing every 2 months, and the vermicomposting would need to be changed once a year. The estimated cost for the materials to maintain this toilet is estimated to be about $30 per year. Coming back to what this toilet is actually able to achieve, for the urine, we have about 1,800 kilograms coming in annually for a family of 5, and we're able to reduce this to 180 kilograms to produce a dry fertilizer while recuperating 85% of the nitrogen. For the feces, we have approximately 330 kilograms, which we're able to reduce to 35 kilograms, including the dry fertilizer being added to it for the ammonia and sanitization. So the exciting part is that we don't need a pump truck. We don't need big machinery to dig holes or to get in and empty it. The mass is reduced by 90% into manageable volumes that people can then handle. And a really important aspect is that the pathogens are minimized so that we don't have the spread of disease. Next, for my thesis work, I'll be testing the alkaline and dehydration module in series, and also be looking at the fate of pathogens in the end product. And this summer we will be installing 2 of these units in Sweden as a trial period. As we're still in the development phase of this, I'm very much looking forward to hearing your comments and thoughts, and thank you very much.
Thank you very much, Jenna. For sticking to the time. Very good. So we've got about 5 minutes for some questions.
Thank you. This is very interesting presentation. I'm Nina from Indonesia. My question is how large is the phases or bleeding from the people who get sick before? And second is what kind of the agriculture or plant can be used for this fertilizer? Because I think if vegetable or fruit maybe it can be a little bit risk to use this fertilizer. Okay, thank you.
Yeah, so if someone, obviously if there's diarrhea going into the toilet, there's risk that the pathogens are still there after the vermicomposting, which is why we do the ammonia sanitization afterwards to make sure that all pathogens are eliminated. And for the fertilizer, and which crops it can be applied to, I will be testing it, but we're pretty confident that we're able to eliminate the pathogens so that it should not pose a risk for spreading disease while being spread on the field, so that the pathogens shouldn't pose a problem. But I will verify this summer to make sure.
Okay, the next question was over there. Make sure when you ask a question that you identify yourself. People will know who you are.
Brian von Hersen from the Climate Foundation. I was wondering if you had observed inactivation of helminth through this process, and by what process do you think the inactivation occurs?
Yeah, great question. We're actually testing that starting March in the urine, so we will be getting more results on that to see if the combination of the high pH and the temperature will be enough to inactivate them.
And is it the urine coupled into the feces, or do you see feces inactivation? Do you expect that as well?
In the feces, we'll have to test it with the ammonia sanitization and see how what log reductions we're able to achieve with that.
Okay, more questions?
I can just quickly say for the ammonia sanitization, actually the work by my colleague already showed that it is effective on ascaris. Yeah, it was shown yesterday in the presentation.
I'm Margaret Morales. My question is, how sensitive is the toilet to either water being introduced into either the urine or the feces part, and to mixing if you get some urine in the feces, then how sensitive is it?
Yeah, great question. So water going into the urine diverting part, so the urine modules, that's okay. It doesn't have any ions, so it won't exhaust the ion exchanger. Well, it has a few ions, but yeah, it won't exhaust the ion exchanger. And in the ash, it has a safety factor on it, so we can accept a few extra liters of water and it won't impact the system. For the vermicomposting, worms are quite sensitive to ammonia, so if we do have urine going into that system, then it could impact it. So the idea is to have enough buffering material within the system already, so that the worms, one, have space to get away from it, but also that it's minimized.
We have time for one more question.
I take from NC State. I'm just curious if there have been any studies into how the users feel about having worms in their toilet and then
Students saying no problem. I think definitely some people would not want it based on talking to some colleagues back home. So it's definitely something that would have to be overcome, but I think there are definitely lots of examples happening around the world now where people are accepting it. But yeah, good question.
Okay, so then we'll stop here with the questions. As I said, you can use the Susanna discussion forum for more discussion. So thank you very much. So our next speaker is Steve Sugden. Steve's been around in the sanitation field for a long time, but I'm sure many of you know him. What I didn't know, and what we found out now, is that he's actually the public health inspector by training, which means he's a qualified meat inspector, having worked in poultry and slaughterhouses in the past, a long time ago. These days he works for Wonderful People. He's based in the UK, but probably traveling all over the place. For example, to Uganda. He supports PSI and various activities for sanitation as a business. He's published articles which are widely read and very nice to read, I have to say. I'm always trying to work, and I look forward to your presentation, which I'm sure will have a little bit of humor injected in it here and there.
Possible. This paper came around when it was traveling around the world, talking to people about their toilets and looking down and realizing that we're missing quite a lot out on the design process. So it all started off, beauty is in the eye of the beholder. So look at these, which is the most beautiful to you? We've all got opinions. Is it the Taj Mahal, the Taj Cottage, the Shard? Is it the fat girl or the thin girl? I'm not very comfortable to come to. Is it a fast Maserati or the electric car? Fashion from times past, the fashion of now. Beauty changes what we consider to be beauty. What is beautiful to you there in that tree? So if beauty is in the height of behold, just certainly going to the question, what is a beautiful tree? And I've heard lots of opinions this time that ecological latrines, biodigesters, concrete slabs, VIP latrines, these are all views driven by what we think the poor people should have. They're not really driven by what the customers want. And this comes from a PSI survey, which shows how people do think about their toilets. That's how you think about your toilet. In a toilet, we feel comfortable to sit. We get peace. If the toilet is dirty, then people would like to come out soon. They have to hurry their business. When it stinks, we have to force ourselves to be there to complete our business. Peace is not there. Now, if we're going to switch from the subsidized process where we give free things away, people will accept those. But if they have to buy them, you're going to have to be selling desirable, beautiful latrines. Toilets are emotional places. They're not just physical structures. And as a sweeping generalization, engineers are not comfortable with emotions. So I just like to, I got the dictionary definition out to help the engineers amongst you all. It's the way we feel. the state of our mind and the uncertainty, our mood, our relationships. These are all emotions. So I didn't know about emotions either. So I read a book. The design student recommended to me, which was the classic book apparently on design. It's emotional design, why we love or hate everyday things. And in this book it explains that we actually operate on 3 different levels in our decision making. The reflective level, the behavioural level, and the visual level. And actually these are all interconnected, so they can influence each other. So at the basic level, this is the visceral level. This is hardwired into all of us. It's the, I'm being attacked, I have to run away. You don't have time to think about this one, you run. It goes back apparently to the days when if you didn't run quick enough or fast enough, you were eaten. So it goes across all the cultures. It isn't just, oh, it doesn't work like that in Africa. Very much to sight, sound, touch and smell. It's often irrational. So the sort of things that create this visceral reaction are things like rats. And we all think things like this is going to happen. Completely irrational. Being scared of heights is very common. Everybody who's not scared of heights, die. If you are scared of heights, it's a built-in protection. Then we get more into this sort of these are, they generate this feeling of disgust. Because disgusting things are generally speaking dangerous and pathogenic. So we've learned to keep our way away from these things. It's very easy to get this reaction. Okay? That's disgusting in any culture you go. Okay? So's that. So's that. Okay? And when you go into a toilet and you see shit lying outside the hole, that's disgusting. No culture in the world thinks that's a nice thing to see. So when we're looking at visceral design, what do we have to consider as the tree design? First of all, the smell of the shit, the sight of the shit, the hint of the shit. Okay? These are all things that have this negative visceral reaction. Flies, insects, rats, deep room pits, dark, miserable compartments. These are all things that we're naturally responsive and opposed to these sorts of stimulation. So what does that mean we have to do? No smell. In Africa they often refer that to, if you take the top off, a wuss come out from the latrine and they call that the heat. So the heat is often very much associated with disease as well. No sight, light, bright areas, no insects, flies, cockroaches, no deep looming pits that you're going to fall down. Particularly when your brother's told you that a big monster lives down the pit. Don't go in there because it's all dark. I mean, would you use a latrine in those circumstances? No bouncing floors, because you might fall through. Missing the squat hole is also very common. So you've got to be able to find your way there quite easily and well ventilated. These are the fundamental things that we really need to be designing. And what do? Concrete slabs. Hey, brilliant. That's our solution. Concrete slabs remove none of those visceral reactions. They are designed, when I first started doing this, the question, are they designed because they're easy to clean and we won't get a scaries on the concrete slabs. That's why we do concrete slabs. Not the household's objective, our objective. Then we get on to behavioural design. This is where we feel more comfortable as engineers. Okay? It's all about functional aspects, all about use. Appearance doesn't really matter. It's a very rational process. It's actually how they describe it, it's like driving a car. Sometimes you're driving a car, you can go 10 kilometers and how do you get there? It's almost instinctive. And then the comfortable things we all feel, plans, the ventilation improved bit of the tree that Peter Morgan developed. Technically inventive. We're going to get rid of the flies, we're going to fly up the vent pipe, we're going to remove the smell. People are negotiating it. What he didn't think about was that to make it work, it had to have a very dark compartment. And if you look at all the VIP trains, the first thing people do is make them light. Septic tanks. Once again, something that the engineers have. We've had quite a lot of discussion on this one. So when you look at these behavioural considerations, these two seem to be cross-cultural. They don't seem to vary too much from South America into India and Africa. Solid walls, we need a good roof. Strong floor which doesn't collapse. Door with locks, preferably both sides. Squatters and sitters, the normal sort of things we go through, washers and wipers, you have to take those into consideration. Well-lit places, so people can see where they're going. Ventilation blocks in the wall. And on the back end, which is probably the bit we're looking at, repeatedly you get this sentence, we want permanence, we want durability. I'm not particularly bothered about its functioning. They don't really care whether it's a tiger worm eating the shit, or a black soldier fly, or it's anaerobic digestion. What they really want is for it to last a long time and not cost them any money. And then we go to the reflective level of design. This is the slower design. This is what talent makes us human, our ability to reflect on our experiences and then apply those experiences to other situations in life. And this is where the self-image comes in. This is where the social norms come in. Wouldn't be right if I open defecated and everybody else was using the toilet. And the products like the mobile phone and the car, these are actually where we express and show our self-image to the outside world. So this is where you have two, from a behavioural point of view, those two watches do exactly the same thing, they tell the time. But the Rolex is obviously a self-image, it's a lot stronger statement about who you are and what you are. And as a result, in the marketing process, the Rolex probably costs about 20 or 30 times more than the Casio. That's why you get Federer advertising Rolex and not Casio. And Casio's big strong message, Casio, now available. Yeah. That's going to make a rush out of that. Cars the same. And we can overcome these fears. Mountain climbers have learned that overcoming this irrational, that fear of height is irrational, you get real adrenaline goes by getting up high. So you can adjust your reflective. The bad news is, engineers, is concrete is ugly. It's not a beautiful product. Okay? Land and boring. What do people want? Saramaka! Yeah, give me tiles. Everywhere you go, people want tiles. People like flush and forget. Okay? They want to emulate the rest, like the rich people have. And what do they want? They want white ceramic. If there are tiles, it will remain clean. It will also look beautiful. Toilet should be beautiful. More than the house, it's a dirty place. However you keep it clean, it will look beautiful. Any colour as long as it's white. Septic tank is best, and this came out in India particularly. You'd say, what's the best form of bucket septic tank? Why? It's most expensive. Why? It's the best. Okay, how does it work? We don't know. It's square. Why is it square? No, we don't know. So there's this high perception that septic tanks are the best and the most expensive. But actually people have no idea how to work. Which is a great opportunity for a market. So the argument is that we have to design the behavior, we have to we're designing to the behavioural level, and we're ignoring the visceral and the reflective levels in our design processes. The solution, design to all three levels. And if you have in doubt, ask you why. Okay? If you are in touch, you'll understand these things. We've got the missing pleasurable at the top. Just a few examples of how we promote toilets in the West. In the West, we have Andrex enriched with aloe vera toilet paper. So obviously, you need aloe vera to spread all over your ass. So promoting lifestyle, promoting self-image. This, I came across this advert, and what's that for? I have to look twice. It's actually an advert for a toilet. Reflection, peace, tranquility. Okay, we show the products. So the only products that we seem to have at the moment that seem to be going really well are things like the flatter, which meets the visual design level, and the Duracell, which we're now promoting in Uganda, and septic tanks, modular septic tanks, low-cost septic tanks that we're developing in India.
Takes a bit more time, but we were a bit generous with our youth. And thank you very much for that inspiring talk. I mean, you built up a lot of curiosity, like you put it, excitement, and I was waiting, so what is your toilet looking like, and what have you got for us? And then you said that one thing, so you don't have the solutions either. You do? Okay. So we need time for another talk where you show us. We only have time for maybe 2 questions or comments from the audience. Anyone? Also, if you have an example of the toilet that fits all those criteria that you
Yes, I'm Pindapra from Nepal. You did a good presentation, but I think if you would have aired affordability, that people can afford or not all these features, and I think if you would have addressed the social and cultural aspect, even if you build the toilet in somewhere in the world, you have their own cultural aspects. They will not use the toilet. Just construct it is the sufficient. So if you would have taken those aspects, you have the right.
There was one comment and a question.
Yeah, just to answer that, I think my hypothesis is that actually there's a huge similarity culturally about what people consider to be the best for training. If you're on the training, designing the training, start at that higher level and work downwards, rather than starting at slab level and working up. I've yet to go to a country where that design of the train say, no, we don't like it.
Does this work? Steve, great, thanks. I'll be the first one to confirm that, paying attention to design and getting away from just engineering is good, but what happens in practice? I mean, in your wondering, where are there examples where you say, we can do this and we can get away from the use of concrete, it's widely in use for a reason. We can get away from having to custom build every toilet. We can get away from the kind of design that meets needs of people without being really expensive. I mean, this is great at a philosophical level. How does it work at a practical level? Where have you seen things, and what can you tell us about how you actually make this happen within the constraints of the communities in which we work?
Yeah. So it goes on this idea that on willingness to pay and the ability to pay is somehow fixed, and that the Casio is always worth as much as the Rolex. I think what happens in practice is that willingness to pay is dynamic. People will pay for more beautiful things. And what we're finding in places like Uganda, where it comes to Eurosam, people they want it, but they can't afford to pay it. So it's the ability to pay. And that's where we have to, and in places like Uganda, we're working with microfinancing. Now, concrete is very functional, and we build walls on concrete. What you really want to look for is that when you open that door, and you look in that toilet for the first time using a bar. So yes, you could have concrete walls, but covering them with tiles disguises the fact that it's concrete. And I think it's important programs to offer the option of putting tiles onto the walls and personalising the entrance.
Okay, there's one more over there, and there was one at the back. Maybe then will be the last one. Hi, I'm Esther from Oxford, and increasingly people are addressing this idea of having an emotional drive behind your products. And one of the things that was brought up in the keynote on the first day was the idea of scale. Now, as soon as you start looking at motivational drivers and personalization of products, it's very hard to do a large-scale program. So, I'm not saying you've got an answer, but do you possibly have some guidance as to how to do a large-scale engineered, safe product while also bringing in the emotional drivers?
This is what might be the solution is that. And it is complicated, it's tied up with supply chains, bad place in supply chains. But this one is, I think, we've got centralised manufacturing of the components of that. Okay, it's concrete. Centralised manufacture of the components that people can buy in, I want a better door, you can buy a better door, you can tiles, tiles. This thing we call the Durasam, and in Uganda we can build in 2 days. And it allows for that personalisation. So I think it's not easy, but sanitation isn't easy. What I'm trying to do is raise the bar and get away from concrete slabs. Let's get to this next level. Let's solve these supply chain problems. The idea is that once you've got a nice toilet, that's it. You don't want another problem solved from that particular factor. The answer will come back a few years and say, I'm not happy with it. But yeah, I think, good point.
Okay, is that a short question?
Yeah.
Okay, short, only question. Such an interesting topic. Don't forget to introduce
Thank you,
yourself.
Steve. And so just I want to make a comment that not all engineers are bad, right? And maybe whatever modular toilet or the septic tank design, still we engineers are involved in the same thing of road purpose, and also septic tank design. There are engineers as well, so getting involved. Not all engineers are bad, right?
Okay, thank you. Then we have a little round of applause. The next presenter is Jess MacArthur. Jess is the technical advisor for water and research at IDE, Bangladesh, based in Dhaka. She's a graduate of the University of Oxford with a master's in water for development. And you were also at the University of Calgary, where you did a BSc in chemical engineering, just like me. Very good people. You're working on sanitation marketing and human-centered design technology development on multiple projects.
Thank you. Thank you very much. I'm Jess MacArthur. Steve, I just want to say I'm a female engineer, so I'm not really sure what you're going to say about that. But hopefully I do have some emotions. We'll see. But I also work on human-centered design, and I'll give a little plug for IDE and what we're doing in Bangladesh right now. We're working with plastics. You showed a great picture of the Sato pan. We're working with the manufacturer of Sato pan in Bangladesh. And we're helping them to move that to a larger scale, to bring that product to Africa and to other parts of the world, but then also helping them to figure out what's the next step. Pasta Sato, working specifically in plastics, in rotomolding. And we're looking at white, so we'll be pleased with that. Hopefully in February, we'll be launching a $20 user interface toilet. So that's like user interface to the entrance of the pit, all in plastics. It'll be mass producible and really easy to move around. So be looking for that and keep watching. So I'm here to chat with you a little bit about what some of the challenges in Bangladesh. We're talking about to seal or not to seal, that is the question, especially in Bangladesh. And if you get a group of practitioners together, we will fight over this a lot. And so I don't want to discuss that as much. I guess I need a slide, don't I? So we were originally going to talk about simplifying the Bangladesh's latrine pit debate through the filter innovation, something that as ID we've been working at through the process of human-centered design. I got to spend 7 weeks in the field doing research, and this is kind of one of the things that came out of that. But really, after a little bit of extra time and after a little monsoon, really I'm going to be chatting about lessons about pit infiltration during the monsoon in southern Bangladesh. So a little bit of a change here in my presentation, but hopefully the learnings will be just as rich. I'm with Proofs. Proofs is a Nexus project looking at agriculture, nutrition, and wash, implemented by ECO, ID, and BOP Innovation Center, and funded by the Dutch. And really quickly, IDE, I work on the WASH and Technology and Innovation team. You can read that quickly if you want, but it's not as important. So when we talk about Bangladesh, Bangladesh is not in the handbook. I don't know if you've ever read a handbook or a guidebook about sanitation, but if you read the fine print, every single fine print relates to Bangladesh. Don't do this in this situation, don't do this in this situation. So high groundwater, monsoon flooding, high population density, small land size, extensive shallow groundwater use for drinking and cooking, pond water use extensively. Every single caveat that's written in these guidebooks is directly related to Bangladesh. And so as I began working there, I started scratching my head thinking, oh my goodness, what are we going to do around sanitation? So we started looking around specifically around what are we going to do in areas, how can we do a simple solution in areas where people are drinking the water that is extracted from the tube well right next to latrine pits. And so many people will say, well, they should be 30 meters apart. They don't have 30 meters of space. Well, then you need a community well. They don't want a community well. No, they already have a tube well on their planned property. So is there a way that we can make a really simple way to protect the seepage coming out of the latrine pit and getting into the water? So we looked at sand envelope pits, which is the WHO recommendation, 0.5 meters of sand all the way around a pit. And we combined that, because sand is quite expensive in Bangladesh. It's kind of funny because the country is entirely made of sand, but it's actually quite expensive and kind of hard to get good quality sand. And combine that with the composting filter latrine, which uses a bag. I've got some mesh here. You can come and see it if you want later. And we got the filto. Let's just stop open. The filter latrine. So there's 2 different varieties of the filto. We'll talk about that in just a moment. This is done a Proofs project in southern Bangladesh. We did 5 test installations and 1 control pit. 4 filto installations, we'll talk about what those 4 were in just a moment, and 1 sand installation. And we did this pilot from May to December of last year. We were prototyping and testing this filter latrine idea in places with high groundwater, with loamy soil, so that's a mixture of sand and clay. And we were looking for bacteria reduction in the infiltration effluent. So we're trying to see if does the sand actually work? The WHO recommends the sand. Is there a way we can reduce the amount of sand that's required? And does it actually work for keeping bacteria from getting into the tube well that's quite close by? So here's what we did. We did 2 different types, 2 different amounts of sand. We did, so in installation A, we did 40 centimeters of sand underneath the pit. So the sealed 3 rings, normal, very traditional Bangladeshi installation. And we used a disc of mesh, just like this, which is what the composting filter bag latrine is. It's coming out of Germany. And then in installation C and D, we used the same amounts of sand, and we used a bag, the actual bag. It's a bit more expensive, a lot more sewing. My sewing gal was kind of confused when I came here with all this mesh. She said, please make me sewing bags. But here's what they look like on the ground. So this is installation B. We haven't quite put all of the rings in B, but this is where the groundwater level is. This is just normal Bangladesh. And we can raise the pits, but this latrine is already higher than their house. And I tried to raise the pit even higher, and they were kind of angry with me. They're like, we don't want to put it higher than our house, which I don't really blame them. So we went to the lowest level that we could. And then installation C, you can see the bag there. So what happened? This is what it looked like when we finalized them. You can see on the bottom there, there's a little plastic baggie over a stick. That's our sampling probe. So we have a sampling probe that goes underneath the sand or pulling off liquid effluent to see what was coming out of the pits. And there's the water. Like I said, not in the handbook. This is where the water is in location of the latrines. This is pretty normal. This is my team and the guy who dug the pit and the family who will be using the toilet. This is before we got the tin on. So this is what happened. We tested the water that was in the pits when we started, and there was contamination. And if you look in installations A, B, C, and D, right through the beginning of the monsoon, we actually had complete removal of bacteria at the bottom of the sand layer. We weren't getting any bacteria coming out. The joke at the DPHE, or the testing facility we were using a governmental testing facility, they were asking us where our well was, because I thought it was really good drinking water, which kind of made me laugh. Didn't tell them where it was actually from. So we were pulling the samples off, and they were coming out with 0 bacteria count. And I was like, wow, this is actually working quite well. And in the sand installation, you could see the bacteria on the y-axis. We got, some count there. And the control pit again. So we were okay, great. So it doesn't really matter if you use the bag or the disc. They both seem to be working reasonably well. And you need the mesh, though. The mesh does help significantly. It helps de-water. It helps keep the water out and the solids in. But it's definitely working better with control. This is just a summarization of that. And then we had the monsoon. And through the monsoon, it was working really well. And we could get there due to flooding. We sent our guys out to take the samples. And then after the monsoon ended, we went back and sampled again. And this is where things gets a little more complicated. We saw a massive spike in installations B and D. Now, this is probably very, very bad from a technical perspective, but I couldn't do uncountable on the y-axis, so I just made it 1,000. We can talk about my methodology, my process in that if you want to at a later time. But, so B and C had this massive spike. I was like, oh my goodness, what's happening? Because the control pit went down to 0 bacteria count. Well, that doesn't work. So I'm like, all right, guys, go back out and sample again. And I went with them to make sure they were sampling correctly. And then we couldn't get any liquid from pits B and D. And we had a spike in A and C. I was like, okay, what is happening? What do we think is going on? And at the same time, our sand spiked to uncountable amounts of bacteria, and our sand, or our control, remained at 0. So here's what I think is happening. I took these pictures that we were installing. If you remember the picture at the beginning where there was that family and my team, and there was a lot of water behind the pit? This is that same installation. And we actually were using an existing latrine pit. We pulled up all of the sludge, and we dug it out and completely started from scratch as we were putting the new pit in. And if you can see here, it's maybe a little bit hard to see, but right where the gaps in the rings would be, we saw a very interesting thing happening that I'm calling channeling. And basically, the fecal sludge is channeling, not radially coming out of the pit, but actually channeling through hydraulic connectivity to the nearest water body. Because you remember how close that water was, right? And so this is what we're actually seeing happening. It's at the level where the gaps would be in the rings. Instead of going radially out, we see this channeling happening. So I went back and I was going through my pictures and I found this. And I said, oh my goodness, this is what's happening. I'm going to do a little diagram here that I'll show you. So in our control, remember it's not sealed to control. So as the monsoon came and it flooded, it's the fecal matter is actually going out, channeling through to the water, and it's not coming down to the bottom of the pit like we would expect it to. And in our filter installations, all 4 of them, we think what's happening is actually channeling in the sand that's going right next to the test sample. So you're not actually getting any of the benefits of the sand. Like, kind of think of like a water filter, like a sand water filter. So as the sludge goes down, and the effluent coming down comes through the sand layer, you get bacterial reduction through 4 different methods. We can talk about that again later. But that wasn't we don't think that's happening because we actually think the sand is channeling out. And you just get a direct channel right to the bottom of the pit. So hopefully this is interesting for you. It was very interesting for me to find these results. So here's what we think. We think that filter pits could work really well in certain systems, certain areas. One of these would be in high density population areas where people are using drinking water from a tube well or from a hand pump, but isn't flooding as regularly. So for example, in cities where you don't get as much flood water, and in northern Bangladesh where they're really drinking the water right next to the latrine. We tested this in southern Bangladesh where the tube wells are a lot deeper, so if we messed up, no one was going to get hurt. But if we bring this up to northern Bangladesh where really it's the tube well, in a nice household, the tube well is supposed to be right next to the toilet, so you have easy access for water to get back and forth. That's the ideal kind of mindset about what's a good home, setup. And if we could put these pits in there where you're not getting as much flooding, but you are reducing the connectivity or the bacterial contamination between the tube well and the latrine, it's very simple. Secondly, we really think that sand envelope pits may not be as effective in reducing contamination as is assumed in literature. And we can tell this by the basics of if you put sand on the bottom of the pit and it's channeling through the monsoon, then really is that as effective as we think it is? Are there ways to decrease the grain size of the sand? Are there ways to keep the sand a bit more condensed and pack it down more so you're not getting the same channeling? And thirdly, our conclusion is we really need to continue to do research. We're going to figure out if we can stop the channeling in our filter installations and also see if this erratic behavior in the pathogen removal or the bacteria removal stops during the dry season. So some different things we need to continue to test and we'll continue to work on. Obviously, this is definitely a work in progress. We haven't sealed this, if you will, and we don't know exactly what we're going to do, but I will just, because I think we have a little bit of extra time, I'll show you the mesh really quickly. It's just finger-leg mesh. I don't know if any of you guys work in agricultural projects or in aquaculture projects. It's just, fishing mesh, and there's 3 layers here. We sew them together. You don't necessarily have to sew them together, you just put them at the bottom. And we use brick chips instead of gravel, because it's really hard to get gravel in Bangladesh. It's very difficult. So just a layer of sand, a layer of gravel or brick chips, and then some of this mesh. And it seems to be working in a very simple way and reducing the amount of sand quite substantially. So, love to take your questions. Thank you very much.
First time I've heard about it or seen it, so trust IDE to come out with something new, very nice. But you said the toilet was white, that's not for a toilet.
Yeah, so we're having a toilet coming out in the new year, in February, that'll be white. That'll be a plastic version. Yeah.
So we have time for some questions. If you have over that way, where's the microphone?
Starting here.
Okay. Don't forget to say who you are.
Yes, hi. My name is Eddie Perez, and thank you for a very interesting presentation. I too am an engineer, but I think that's kind of a reformed or failed lapsed engineer. Having just come from Bangladesh recently, I noted that Bangladesh is still one of the poorest countries in the world, with about 60% of the population living in extreme poverty of $1.50 a day, basically. So my question is, ballpark, I realize it's early stages, what is the cost of that whole package? And so in terms of how affordable and feasible it is in society. But my real question, my second question is really, I don't really understand the goal. Is this improving health? Is drinking water from the tube wells that has some fecal contamination, is that really the highest risk that those families have to eating shit?
Yeah, great question. So, I mean, the addition of this mesh and really the sand, it's about maybe a $2 fix. It's very, very cheap on what they're already putting in the ground. So, as far as the additional cost, very, very minimal. And they probably already have the nets kicking around their house in Bangladesh, and the sand is also widely available. Great question about what the point is. Yeah. So, in areas of Bangladesh that I'm working, when we can discuss what the best benefit is, what the most benefit is, and we can go into the stats on that. But we're trying to protect on multiple different levels. We're doing a tube well project where we've developed a low-cost tube well platform for about 1/5 of the cost of normal platforms. It's about a $6 platform that they can put into their house really cost effectively and very simply. So we're trying to protect the tube well from that perspective, but then also protecting what they're pulling from the ground. And that's where we see there's a lot of cross-contamination. 41% of tube wells in some areas of Bangladesh are contaminated with fecal matter. And so if you think about people actually drinking literally their own poop because they're taking water from very close to the latrine. And so we're trying to find a way to decrease that cross-contamination between the tube well water and the latrine. Does that answer your question?
Hello, this is Janice from India. My question is, what provisions have been made to have the toilet user-friendly? First thing, second is the accessibility for users. And is there any provision of providing some lights to use the toilets in late evening or early in the morning? The people can reach there.
Yeah, great question. So really we were just testing what was happening under the ground. We're using an existing toilet called the FFT, which is an IDE toilet. If you're familiar with the toilets that are done by IDE in Cambodia, it's a similar version to that. But definitely that's something we're working on. We're developing kind of in tandem the superstructure, the substructure, and what we're calling the mid structure, or that user interface. And so this project is really focusing on the substructure. But yeah, great, I agree completely.
I'm Mark Jesus of Duke University. I work with meshes in a very different context, and they tend to plug very quickly. I wanted to hear your comments on possibility of plugging over time.
Great. Absolutely, come find me afterwards, it'd be great. Yeah, I think this mesh is really widely available in Bangladesh, but we're looking for ways to increase the ability of this product to really work in different ways. So if we can find different types of mesh, that'd be great.
No, but clogging of the mesh.
Oh, clogging, I'm sorry. Yeah, so that's one thing we haven't done. Once these pits fill, we will be able to empty them after a set amount of time and then actually see what's happening. We don't know what's happening on the ground. That's great. I really think that's something we need to work on. And hopefully once we see if the pits are filling up. We've been testing to see if they fill up. The average household uses about 63 liters of water and sludge per day in Bangladesh. And so we figure if it's filling up really quickly, we'll know it's clogging. And so far we haven't had anything fill or spill yet. So.
The channeling theory came across something like this in India when it was rats that were causing it. Was there any evidence of rats activity?
Yeah, not in this particular pit. I mean, definitely there were in other pits, but we didn't see the same channeling in those pits we did see the rats in. So definitely something that I thought about. It would be good to be able to dig these pits up and see. Like I said, it's just a theory right now, and because we want to continue testing. If we dig them up, then we can't continue to test. So yeah, if anyone has any experience with that, I'd love to hear from them.
Barnum Metropolitan University, very interesting presentation. Based on your conclusions, I thought channeling is something that you have to deal with. And it is not that channeling happens during or after the wet season, but it is not a problem during the dry season. It just happens quicker during the wet season or after the wet season. So even under dry conditions, that is something that you probably have to deal with, and it will happen, but it will happen in a longer time.
Yeah, I think that's accurate. I think what we saw through the first 9 weeks of the study is that we weren't really seeing any channeling because we were getting 100% bacteria removal. But we want to continue to test and see if that really is happening during the dry season, like I say.
Okay, last question from George.
Hi, George Michael from WhatsApp. Interesting presentation, very nice. I just had a question about your control. I'm wondering if you have any ideas why it went down to 0, if Alice is correct.
Yeah, that's a great question. So I think in one of my slides, I don't want to pull it up because I know we're rushed of time, the control pit was not sealed. And so I actually think what was happening is you were getting leakage of the fecal matter out through the seams between the rings, like you would expect. And so my other thought is that perhaps it was being, the solution to pollution is dilution. So as the monsoon came in, it was like we actually removed a lot of the matter from the bottom of the pit, and then there might have been a layer, a harder layer, impermeable layer of sludge formed, and then you're getting spillage through the gaps. That's my only theory right now, but if you have any other ideas, I'd love to hear them.
Okay, well, thank you very much. It was really interesting. and thank you for all your questions. Another round of applause. Okay, before we move on to the next presenter, I was told to give you one piece of information here. For those people who have papers at this conference, if you want to submit the article to the journal, it's called the IWA Wash Development Journal, then you're supposed to send it in before the end of the conference, I was told, to the conference organizers. Or there's an email address probably on the website. So don't forget to do that. Then the next presenter is Jing Ling. Jing is from China. His company is called Beijing Sunny Breeze Technology. His background is in the nuclear waste disposal. He said it's basically the same thing as before sludge waste. He was a visiting scholar at New York University for 5 years, and he's also an engineer, an electrical engineer, and he's got a PhD in geoscience. So,
Thank you for introducing. Our engineer team from the nuclear waste disposal field. So when we face the reinventing toilet program, the challenge in our like the professional views, the key should be evaporation. The first should be is remove liquid portion from the human waste by the means of evaporation. Our system includes 3 parts: toilet, black water tank, and on-site waste processors. The output is condensed water and pasteurized solid powder. This is our minimum flushing toilet. Evaporation is high energy consumption. It spends a lot of energy. So before we process the black water, we need to cut down the amount of the black water from the original source. So we designed this minimum flushing toilet. Just want to cut down the amount of the black water. What's new for this? Here include 2 pumps. One is microwave pump, and the second is car washing pump. You can see the toilet paper was pressed. The toilet paper was pressed, and it's okay. The toilet paper was pressed, and the piece hard part was pressed. They can use the small diameter soft tube to transport a long distance. Second video. The flushing is different from the current. These 4 flushing hoses, step by step, one by one, the flushing. That's 2 reasons. First, we use the car washing pump to offer the high press water. If we take a knot like this, offer enough press to the 4 hose. That's the first reason. The second reason is most applications only like the spot and the dirty a small part. So we only use one flushing hose that can save flushing water. The second part is black wall tank. Why we need black wall tank? Because in the rainy days, black water storage is much easier and reliable than use the electricity to store solar electricity. Now the hard part, on-site human waste processors. There are many challenges for design on-site human waste processors, but I think the most hard part is the first is energy. The first is energy imbalance. The second hard part is the system is really easy to clean. Focus on challenge 1. When use the solar offer the electricity for power, it's very limited, but evaporation needs a lot of energy. It's high energy consumptions. To balance the energy, the solution, first solution is we just have minimum flushing quality, limited amount of the black water, but that's not enough because you cannot limit the P multiplication. So the second idea is MVR evaporator. What is MVR evaporator? First, the common evaporation includes 3 parts: vapor, evaporator, and the heating source. The MVR means mechanical vapor recompression. Use MVR. The vapor is collected and pushed to the mechanical compressor. The vapor was compressed by the compressor, and distilled water was condensed, and the inner heat of the vapor was released. This inner heat used to heating source. The heating source from the river instead the previously heating source. They offer the hot energy. So this system saves a lot of energy. Generally speaking, MVR technology can save more than 90% pipe energy. MVR is not new technologies. It's over 50 years, but most used in the heavy industries. For example, in the distillation plant, get the fresh water from the sea. Our job is to develop a low-cost, finely scaled, small-sized MVR human waste process last year. The most hard part here is we cannot find correct compressor. The typical compressor is industry and VR, but there are no proper compressor in the market. So we brought about different small size compressor, and we try to rebuild it. And very lucky we success on this and built a small NVR compressors. That's about $200 and about 8 watts and lightweight. The second challenge is cleaning. You may have this experience. Your kettle in the kitchen is really easy to, like the scale first, that use the clean water. So you can use the black water or rose water. The system will be very quickly to stop work. So without proper measures, the system cannot work. The simple idea is screw and ball systems. We put some balls in the boilers. The boilers, we do this. So use this kind of thing makes the system self-clean. Last year we tried a different way to build NVR processors. This inside of the evaporator. Different shape, different size. There's the whole system, toilet, black water tank, and the waste processor. Okay. Now, we test these systems. First, NVR. The system much more like boilers. Distilled water.
Remember, you can run it out of time.
So distilled water. This the quality of the condensed water is quite good. pH. Output of dry sludge. No. This is the pasteurized powders, solid powders. Summary: the liquid fluorescent toilet is really flexible. NVR technologies most promising, like the solve the problem of the energy imbalance. The compressor used NVR we built is a lot of room to improvement. So in the future, this processor can reduce smaller than this. There's still some problems we're working on, and include how to control the odors and how to make the system stabilities, etc. Okay, that's all.
And for your interesting videos. I'm really sorry, but you have gone a bit over and we are running a bit late. So I won't take any questions now. But the good news is that he has written on the Susanna discussion forum about his process, and people have asked him questions there. You're very welcome to go there and check what has been asked already. And I didn't understand it all, so I have to also go back and read more about it. But very interesting process. Thank you. So, as I said, we have one person who's not in the program who is now going to present. He's called Hezron Magambo. He was in the program for one day. He's from Tanzania, where he works for the Center for Community Initiatives. Sorry, I don't have your bio in front of me, but I don't know, are you an engineer as well? Oh, okay, sorry, we've got a session full of engineers here and so forth. And his presentation is about fecal sludge management in informal settlements in urban Tanzania and Iceland.
My name is Hezron Magambo from Tanzania. I'm working with an institution called Center for Community Initiatives in Dar es Salaam, Tanzania. I'm also a water and sanitation engineer. So I'm here to share with you, I'd like to share with you a little bit about fecal sludge management at our local context in Tanzania, particularly in Dar es Salaam. My presentation will be a little bit different because I'm not talking about the on-site and the design, contrary to my people, to the other business presenters. I've been talking in particular what happens after the toilet, after the pit is full. What happens after the pit is full. So, so I'll talk a little bit about my organization. Center for Community Initiatives is a non-for-profit organization that was started in 2004 with the aim of helping poor people to develop a quality life with sustainable solutions. We're working in 8 cities of Tanzania. Working to support the community to form savings groups, we call them the Federation Group. They're all over. Today we have about 14,000 federation members who meet together on weekend basis, and they collect their savings for loaning to livelihood, and also they collect savings, they call it Urban Poor Fund, which at our local level we call it Jenga, which this fund is for providing loans for bigger development projects. We also want to empower them to collect data through innovation and mapping, which later on this data is used for negotiation with the government, because they have to do a lot of advocacy to get things done in our country. We want to build their capacity, like we build the capacity to train them and let them do things, plan, implement, and manage projects. So, what's happening in Tanzania? Tanzania is the fastest growing country with a growth rate of 2.8%. Currently, the population is about 44 million people. With the rural urban which has led to the formation of informal settlements. And these informal settlements lack proper infrastructure, people start building infrastructure, road infrastructure, and 92% of the households of Tanzania are using pit latrines. So you can see pit latrines are the main mode of sanitation facility that is used in Tanzania. And the coverage of the goods toilets that are not shared is only 15%. So speaking of Dar es Salaam now, which is the major city of Tanzania, with a population of around 44 million people, about 70% live in the informal settlements, where they lack infrastructure, they lack post-grad military services, and so on. So the communities have been using alternative means. So if they don't have this infrastructure of post-grad management, then they go to alternative means. So they've been opening up the toilets, doing great, and flush the waste with it. They've been flushing the waste direct to the water sources. They've been digging up pits and buying the sludge as a solution. So like those who can afford, who can access, who have access to roads, I think those who live not, who do not live in the informal settlements, then they can afford the trucks, the vacuum trucks, which cost at least 57 up to 152 USD. And people living in the informal settlement, they can't afford it. So this is the situation now. You see an old man thinking on, okay, my toilet is now full, the pit is full. What should I do? He digs up the pit and then buys the sludge. You see the situation in most places in So, a Gulpa machine was invented. At first it started as a research and then developed a program. So, Facebook Water in Tanzania recognized the program, and then with other stakeholders, they started a group of projects. So the group now in this particular case study started in 2010 with one settlement, which now we have scaled up to 5 more settlements. So the group itself is composed of a cycle that can at least trespass with informal settlements, and a hand pump that is pumped manually, and a container of around 350 liters. So they came up, they come to your house, they pump your pieces, and then they transport it to the ponds, which are a big distance, at least 30, 40 kilometers. So the challenge has been the distance covered, and with the logistics of Dar es Salaam, it's high populated, a lot of traffic jams. So it was a challenge. The distance that was being covered by these group operators was huge. So people started thinking about having decentralized wastewater treatment systems. So they said, okay, why should we have a decentralized wastewater treatment system to solve this challenge? It was designed by Boulder. So now they have a decentralized wastewater treatment system at site, which they can get biogas out of it, and then they can get manure, and then the effluent of it can be used to condition the soil. So the cost of PTMP is at least 15 to 24 USD per 55 liters per tank. With that type of quality fit, 1 liter is 55 liters. So this depends on the toilet, the depth of the toilet. And but again, it allows for flexibility. For those who cannot afford, then they can negotiate. Or okay, if you cannot afford to do the good toilet, then you can do part of it with the amount of money you have. So this is the actual process. Again, with the pit emptying the group, you have first to deal with the solid waste, because pits in informal settlements, in most cases, you'll find that they use it not only as a pit latrine, but also a dustbin. It's where they throw everything, they throw pieces of papers, they throw pieces of clothes. So it's hard for a group of people to work. So you have to deal first with solid waste, and then you You do the actual pumping, you fill your tank, and then you go to the dumping station. So, tempting as an element of business, it has an element of business in it, and this is an example of a monthly report from MAO that I collected from MAO. The income generated in a month is at least 1,000 USD. When you take down all the operation costs, operators, and communications, distributors, then they have at least a profit of about 500 USD per month, which is not bad. So we're saying that the centralized water treatment system has helped to improve the group business by increasing the market niche. Previously, we used to sell only four trips, and now we're selling up 8 trips a day. And also, has increased the annual revenue. At least they used to collect previously about 1,200 USD, but now they're collecting up to 4,000 USD. That is between 2013 and 2014. It has improved the sales delivered by group. Now they are proud now. They can even say more of the cost now. Okay, we can provide service at any time. So cost is a bit high, so they're making more money. But then if they cut down the cost of operations, the cost has been reduced due to the distance. The cost that was caused by distance cover has been reduced from 300 USD to 30 USD per month. It has increased popularity of Groupa. Now Groupa is well known all over Tanzania. And every settlement wants to have it because of this very city. So on scaling up now, we're looking to involve more the government through expertise, because we have some expertise from the government, and through education and promotion. But then there is an increased interest with sanitation stakeholders. For example, JZ and board are now willing to invest in the group. Microfinance institutions are now interested, according to the recent research, like the few microfinance institutions, they're interested in putting in money to do this business. And the organization now, CCI, has secured funds to scale up and to move two more settlements. But this is not enough, but it's enough to lobby the government and try to scale up. And then there is a need of highly community mobilized. Yes, we say that Mao Group is a success story, but then we realize that we are doing that not so much, it's not so much owned by the community, because it is like one group driving everything. So we need more, everyone in the community to understand and drive the project. I think there is a need to look for other product solutions of managing with people's lives. Example, we have started a small project of simplified sewage. A small project of simplified sewage, where we started with 20 houses to see waste. And this project now involves a lot of stakeholders. It involves the government, it involves the utilities, and the community life. The challenges of emptying, as usual, emptying things are full of solid waste. So you have treatments of solid waste, and then deal with the people's life. And then the long distance travel to dumping sites, 30 to 40 kilometers, high demand of the service, especially in the water, Mars. But then lack of good financing mechanisms where they already exist in Europe. But then we think financing and investment, but not so many finances. It's those finances that were part of the research. And the challenge of this group activity model has been the variation in the effort. This is an example of percentage remove of people polyform that was started. As you see, it varies. Sometimes it drops to 8%. So there should be some improvement. So with what studies have been undertaken on how to improve group, what area are working with CDO, and other universities at the local context. They are looking into moving from manual to modernizing. Improve the quality of keyword reference. What are now constructing standard feature to make sure that the quality of reference is improved. Increase number of business entrepreneurs interested in anything. So we are promoting and mobilizing the number of people interested. So achieving sustainable fitness management is improvement to what is possible. Need to involve more community and more success story, then we need to involve more municipalities and activities. So to conclude, we think other options of sanitation, alternatives like this should be explored. For example, I was very interested to see the technical street. And then to reach wider scale, at our local context, we need to do co-production initiatives, which link the community, the government, and other activities. Thank you very much.